Hey YouTube, welcome back. Today we have a new problem number 16, three sum closest. Let's see if this problem has been, this problem has been asked not that much, but okay, it's still important one to tackle. So let's look at it. Given an integer array nums of length n and an integer target, find three integers in nums such that the sum is closest to a target. Return the sum of three integers. You may assume that each input would have exactly one solution. Okay, so each input exactly will have one solution. That's great. So if we have this one, the closest one, it will be 1 because -1 to 2 plus 1, it will have 2, and the difference between this and target is 1. Here the target will be 1 because all of the zeros with each other will be 0 and difference will be 1. So the way we can solve this problem is that let me take this. And put it here so we can just talk about the problem easier. So the way we can solve this problem, we can use like a two-pointer solution. Like let's first we could create two variables, like one can I make it smaller? It will be the actual difference, and the other one, it will be the closest sum, which will be equals, for example, 0, and the difference, it will equals let's say 0 currently. And we will try to use a two-pointer solution. So we try to loop first, and let's change the color. We try to loop first here and use two pointers. So we use one pointer to next to the element, the first looped element, and another pointer to the last. And also we could just first, before using the two pointer, we can sort the array, so it will be easier for us to tackle it. So it will be -4, -4, and -1, and 1, and 2. And after sorting the array, we try to loop first to get the first element, loop element by element, and we have two pointer. One, it will be here in the next element, and the other will be at last. And we have three numbers, and we try to know the full sum of these three numbers, and we put the full sum here, and we just try to compare it. I guess the difference could be like let's call it, like, could be infinity, the difference at the beginning. And we see if the closest sum and the actual target, the difference is smaller than the actual diff or not. If it's smaller, let's not make it 0, let's make it infinity, because it's 0, it will be, oh no, let's call it infinity. And after that, we try to like, right now we have 3, and we have these 3, and we store it in closest sum, and we just try to find the difference between them and between the target. We will get a target element, and when we try to find the differences, and we see if the difference is smaller than this difference, if it's yes, we try to update it, and we continue looping to all the numbers. And by this one, we will find our solution. Let's just try to see. So first, we could just do like closest. Let's create like let closest sum, and this one will equals nums of 0 plus nums of 1 plus nums of 2. We could also make it infinity, but because we assume that each input would have exactly one solution, we can go with this one. Let the difference will equals math dot absolute, because we don't know which one is bigger, target minus closest sum. Okay, and after that I guess we should sort it. Nums dot sort A and B and A minus B. I will do a for loop. Let's call it for let I equal 0 and I less than nums dot length minus 2, because we stop there, and I plus plus, and I will say let low equals I plus 1 and let high equals nums dot length minus 1, and I will say while low is smaller than high, because we don't want to make low bigger. I will get the sum first. Let sum, it will equals nums of I plus nums of low plus nums of high, and let's go like let's get the current diff, which will equals math dot absolute target minus sum, and I'll say if current different smaller than the different, we should do two things. First, we should update the different. We should different will equals current different, and also we should like the closest, we should update the closest sum will equals sum. Okay, and I will say other thing that also if sum if smaller than target, if sum was smaller than target, we try to go to bigger numbers, so we add 1 to low. If else, we could take 1 from high, and I should return the closest sum. Let's see if this will work. Run. Why it's like that? Why? Let's run. Yeah, let's submit. Okay, it did work. Let's just try to describe what happened here. So first, the tree sum closest function takes an array of integers called nums and integer an integer called target as an input, and returns the closest possible sum of 3 elements in the arrays to the target value. Okay, this value. At the beginning, we initialize closest sum, which is a sum of the first 3 elements of the sorted nums array, and difference and diff. We have this one diff, and diff it's with the absolute difference between the target and the closest sum. After that, the nums array is sorted in ascending order to simplify the search process. And after that, the function then uses nested loop to iterate through the array, considering each element as a potential starting point for nums of I for a triple sum. And after that, inside the nested loop, we have 2 pointers, low and high, and the low and high are used to find the other 2 elements of the triplet sum. The low pointer starts just after the current elements, and the high pointer starts at the end of the array. For each triplet sum, it calculates the current absolute difference. We have this one. We calculate the current absolute difference. It's like the current diff between the sum and the target. If the current diff is smaller than the previous recorded difference or diff, it updates it. It updates both the difference and the closest sum. After that, depending on whether the sum is less than or greater than the target, it adjusts the low and high pointers according to move closer to target value, or out than that. After that, the process continues until the loop exhausts all possible triples. Finally, the function returns the closest sum, which represents the sum of the triple that is closest to the target value. And yeah, the solution beats 92%. It's not that bad. It's good. It's fucking good. To be honest, it's good. So yeah, that's it for today's video, and I hope you like my description. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you in future problems.